I would like to now introduce you to, by this, can we put the picture up of our five panelists, maybe, the slide? And we're going to start with Jack Gilbert from the University of Chicago. Thank you.
I'm Dr. Jack Gilbert, and you're covered in bacteria.
Microbiologist Jack Gilbert studies how microbial communities assemble themselves in natural and man-made environments. Gilbert's goal is to characterize all of the microbes on the planet. His team has already identified more than 22 million species from samples submitted by hundreds of people around the world.
So you have 100 trillion bacterial cells inside your body. And what we're starting to understand is by looking at those organisms, we can say intricate things about your health and your well-being.
Ladies and gentlemen, please welcome Jack Gilbert.
Thank you very much. It's a great honor to be here. My name is Jack Gilbert. I'm a professor of surgery at the University of Chicago. And what I want to talk to you today about is a revolution in ecology, which sounds a little bit unusual for a medical session, but I am an ecologist. I'm an ecologist that's been hired into a medical department to help to revolutionize medicine. If I was to tell you how we currently understand disease and the human genome, you might understand that principle. We've heard about the rush of detail in trying to understand the human genome, link it to disease, and find out those individual genes which are responsible for the disease. I myself have an APOE mutation, which leads me open to having a heightened susceptibility to developing Alzheimer's. My mother has twice the risk due to a double mutation. And does this mean I'm going to get Alzheimer's? I know I have an increased risk, but what are the factors that would lead to its onset? Well, it's important to understand you're not just a human genome. You're a microbial genome as well. In fact, you are 100 trillion microbial genomes. Around 3 pounds of your body mass is bacteria, viruses, fungi. And they collectively have 100 times the amount of genetic information that your own genome does. And they are with you from birth. They are given to you by your mother. In the initial phases. You're born mostly sterile. You get your bacteria from your mother during birth, and then even from her breast milk and her physical interaction, and then from your family, and then from that dog that licked you on the face that time, and then from the mud you played in and made those lovely little patty cakes that you showed to your mum and she didn't like those. I got that. So we had a fundamental interaction with the environment. Right now even, each one of you is releasing 36 million bacterial cells into your immediate vicinity every hour. So you're all becoming more microbiologically similar, okay? And those bacteria are colonizing you like an island. And fundamentally, you need them for your health, okay? You need them in your body, you need them to be there. But over the last 100 years, we've been doing something rather negative. We've been eradicating that exposure to the microbial world, which our species, over the last 5 million years of our evolution, has become dependent on. We've been eroding, almost deforesting our own microbiome through the indiscriminate use of antibiotics, through cleaning products which help us to protect ourselves from the 99.9% of bacteria which are going to kill us instantly. It's not true. That removal of us from our environment has been a fundamental problem in the development of our health. We think this has led to asthma, allergies being significantly increased, and many other conditions. In fact, through what I call microbiome-wide association studies, this is akin to a genome-wide association study we heard about earlier, where we would link a gene in the human genome to a disease. Here we're linking microbial ecology, so hundreds of different species of bacteria to disease. We've found hundreds of different conditions which have been linked to changes in the microbiome or have been linked to being onset or delivered by changes in the microbiome. So a couple of examples of this, researchers at University of Chicago and across the country have uncovered fantastic new therapies for treating cancer. Immunotherapies, which we heard about across this conference. And yet, what we found is that there are still people that do not respond particularly well to the immunotherapy. In cutting-edge research, we found that by adding certain bacteria back into the experience, into the body of these people, we can significantly accelerate the success rate of that immunotherapy. This is fundamental. We're adding a probiotic. Not any old probiotic, a very specific probiotic, but a probiotic back into the experience of these people, which is improving the efficacy of their medical treatment. We know that neurocognitive disorders, in my own work on depression and anxiety and even autism, and even neurodegenerative disorders such as Parkinson's or Alzheimer's, have actually been linked to changes in the microbiome. In our animal studies, we've shown that by adding certain bacteria back into a mouse that's predisposed to Alzheimer's, we can prevent the mouse from developing it. Imagine if we could transcend that therapy very rapidly through improving our connectivity across scientific disciplines to enable us to take those findings in the lab and put them into the clinic as quickly as possible. We're nearly there. We need to push ourselves harder to transcend that boundary. And then we wouldn't just be able to treat Alzheimer's with these microbial therapies, we'd be able to treat other conditions. Imagine treating depression. Imagine really being able to attack this problem which has massive consequences for our society, let alone societies across the world. Depression is a major problem in our world. And if we could treat it, we could have a real impact upon humanity. Surgical infections. In our own work, I'm an ecologist, actually a marine ecologist, if you would believe it, working in a surgery department. And it's my job to try and find out ways in which my understanding of microbial ecology in the ocean can be transcended into a surgical theater to determine ways to treat the microbiome as well as treating the patient. Imagine how traumatic a surgery is to the body of the human being that's undergoing the surgery, okay? And then imagine how traumatic it is to the bacteria in there. We normally don't care about them, right? We try and kill them off because they could be dangerous. What we found in our study is that by eradicating that mentality and feeding the microbiome during surgery, the bacteria, the 100 trillion bacteria inside your intestine, we can actually prevent them from going rogue, from attacking the host. We give them a novel therapy, which we developed with material scientists and computer scientists who helped us to model that dynamic. And when we add this in, the bacteria are satiated. And they no longer, when stressed, attack the host. This is transformative. We believe we can eradicate 90% of surgical infections by using this kind of technology. And are trying to implement that right now. So, moving on to an understanding of how to attack this in humanity, I want to propose a concept we call microbial GPS. I want to be able to give each of you a GPS to your microbial health, because not all of you can change your genome, but you can certainly change your microbiome, and you do it on a regular basis. The food you're eating right now is changing your microbiome. Imagine if I could tell you exactly what you needed to do to get your microbiome back to optimal health. What kind of probiotics you might be able to take, what kind of diet you might be able to use, what kind of lifestyle you should adopt. Maybe I should tell you to go and get a dog or rescue a dog. Maybe you need to take a particular antibiotic to treat it, and then eradicating that's going to have massive implications. So we are proposing microbial GPS as a way of transcending our ability to take control of our health and our life. The University of Chicago is a research university. Argonne National Laboratory, part of the Department of Energy's National Lab Network, and the Marine Biological Laboratory, a marine institute, we're taking research from agricultural microbiology, attempts to improve productivity, disease resistance, and tolerance in plants, from the marine sector, and from climate activity research, trying to figure out ways of taking that data, transcending our boundaries as researchers, and applying it to the next generation of microbial research. So I think this is an incredibly exciting time because we are moving across those boundaries and presenting the future of healthcare from an ecologist's perspective. Thank you.